Mercury is the closest planet to the Sun. It is also the smallest planet in the solar system, not much bigger than the Moon. If you were standing on Mercury, the Sun would look about 3 times bigger in the sky. Mercury is a terrestrial or rocky planet, just like the Earth. It is made mainly of iron and other heavy metals and has a rocky crust. The core of the planet reaches over halfway to the surface. It is the second most dense planet in the solar system after the Earth. Mercury is covered in craters like the Moon. Most of the craters were made billions of years ago when the solar system was forming. Mercury is the only rocky planet which doesn't have volcanoes. This means that the ancient craters can still be seen today, as the surface has not changed much since its creation. It has no moon of its own. Mercury is the least explored of the 4 rocky planets of the inner solar system. It took until 2011 for the first spacecraft, NASA's probe Messenger, to enter into orbit around the planet. In comparison, Jupiter, roughly 5 times more distant from Earth, welcomed its first orbiter already in the 1990s. Mercury is also notoriously difficult to observe from Earth. Here, we present 3 most significant obstacles in the exploration of Mercury. Out of the 5 planets known since ancient times as the wandering stars, Mercury is the one that's known as the least explored. Unlike Venus, Mars, Jupiter, and Saturn, Mercury is notoriously difficult to observe from Earth. Being the innermost planet of the solar system, it always appears too close to the Sun. While the golden time for astronomical observations is at night, Mercury sets and rises in the sky nearly together with the Sun. That means it can be spotted only briefly shortly before sunrise and just after sunset, and always appears close to the horizon. Although the planet can be observed with telescopes during daytime, astronomers need to take extra precautions since the intense sunlight and the constant proximity of the Sun could damage the optics. Larger telescopes are frequently not allowed to look in the direction of the Sun at all because of the damage they could sustain. Interestingly, one of the most powerful astronomical observatories to date, the legendary NASA/ESA Hubble Space Telescope, never imaged Mercury. Orbiting Earth at an altitude of about 550 kilometers, Hubble observed some very distant celestial objects, such as the blue supergiant star nicknamed Icarus, some 14 billion light-years away. It has, however, never looked at Mercury out of concerns about damaging its sensitive optics. Although NASA's Mariner 10 flew past Mercury 3 times in the early 1970s, while orbiting the Sun, it took until 2011 for the first mission ever. That's the NASA's Messenger, to enter into orbit directly around Mercury. In comparison, Mars received its first orbiter in 1971 and Venus in 1975. Jupiter had its closest nearly 630 million kilometers away from Earth compared to Mercury's average 77 million kilometers, welcomed its first orbiter in 1995. Even the more distant Saturn preceded Mercury with the Cassini's mission, a joint project by NASA, ESA, and the Italian Space Agency by 7 years. With these expeditions, you cannot avoid to ask, why is Mercury so little studied? After the three brief Mariner 10 flybys in 1973 and 1974, nothing happened in the exploration of the innermost planet of the solar system for nearly 4 decades. Surprisingly, despite being much closer to the Earth than Jupiter and Saturn, Mercury is actually more difficult to reach. According to some estimates, it would take less energy to get to the dwarf planet Pluto than it takes to get to Mercury. The reason for that is Mercury's closeness to the Sun. A spacecraft aiming to not only fly past Mercury while in orbit around the Sun, but to enter into orbit around the planet directly, has to constantly brake against the gravitational pull of the star. There are two ways how to accomplish this braking, says Johannes Benkoff, ESA's project scientist for Bepi-Colombo mission. You either have a huge spacecraft that carries a lot of fuel, or you can use the gravity of other planets to slow you down along the way. To reach Mercury, you need to perform multiple such planetary flybys, and so the journey takes a long time. It takes less than 2 years to ESA Sun Explorer solar orbiter to reach its target orbit around the Sun, which is even closer to our planet star than Mercury. Bepi-Colombo, surprisingly, needs 7 years to put itself in the right position to place its two orbiters, ESA's Mercury Planetary Orbiter, or MPO, and the Mercury Magnetospheric Orbiter of the Japan Aerospace Exploration Agency, or JAXA, into the right orbits around Mercury. To get there, the spacecraft has to perform an overall 9 gravity assist maneuvers or flybys that will help it brake and adjust its trajectory. Among the pioneers studying the use of planetary flybys to correct trajectories of space missions was Italian engineer Giuseppe Bepi-Colombo. It was Bepi-Colombo who proposed to optimize the path of Mariner 10 by performing a flyby at Venus to eventually achieve overall 3 flybys of Mercury instead of the originally planned one. It is his name that present European-Japanese Mercury mission Bepi-Colombo carries. We obtain most of the energy to get to Mercury from the flybys, said Johannes. We use our fuel mainly to get the flyby right, to bring the spacecraft into the correct position when we fly past the planet in order to get maximum energy out of it in order to brake and go into the right direction to the Sun. The closest NASA's Mariner 10 got to the surface of Mercury during one of its 3 brief encounters was 327 kilometers. The Messenger spacecraft orbited Mercury between 2011 and 2015 on an elliptical orbit that somewhat changed over the years. The closest point of the orbit got to about 200 kilometers from Mercury's surface, while the furthest shifted from the initial 15,200 kilometers to approximately 9,000 kilometers towards the end of its mission. ESA's Mercury Planetary Orbiter, or MPO, one of the 2 orbiters comprising the Bepi-Colombo mission, will follow a much tighter orbit around Mercury with the nearest point at the initial distance of 480 kilometers from the surface and the farthest at only 1,500 kilometers. Over time, the orbit of the Bepi-Colombo will change and the nearest point to the surface will move down to about 200 kilometers before it races again. Even though both Mariner 10 and Messenger may have briefly made closer approaches, they didn't stay in the scorching heat near Mercury continuously. As a result, neither mission obtained high-resolution data over the entire surface of the planet, something Bepi-Colombo should fix. The ambitious plans that European scientists have for Bepi-Colombo stretch the engineering teams of ESA and its collaborators to their limits. Daniel Stramaccioni, ESA's Bepi-Colombo system engineer, compared the situation that Bepi-Colombo will face to sticking a working laptop inside a hot pizza oven. Bepi Colombo is a mission like no other, he says. Some 80% of its equipment had to be developed from scratch. Without widespread innovation, it would have never flown. At the time of its development, Bepi Colombo was set to face a harsher environment than any ESA mission before. Not only is sunlight around Mercury about 10 times more intense than near Earth, the planet's scorched surface also radiates heat back to space. As a result, MPO will have to endure temperatures of up to 450 degrees Celsius, hot enough to melt lead. Materials used in standard space missions are not capable of withstanding such high temperatures. For example, standard solar arrays start falling apart at 140 degrees Celsius. The engineers, therefore, had to find a completely new materials for the job. A carbon fiber reinforced polymer enables stretching the workable temperature of the solar panels to over 200 degrees Celsius. But the arrays still need to be tilted up to 70 degrees to reduce sun exposure. Solar panel technology was one of the make or break issues for the mission, and setbacks in its development brought the project at one point to the brink of cancellation. The MPO is also fitted with a complex system of cooling pipes that transport heat from within the spacecraft to radiators attached to its shaded side. These radiators, together with dozens of layers of space insulation, keep the MPO's interior within room temperature, which is important for the spacecraft's sensitive instruments. The insulation blankets, consisting of titanium, aluminum, and ceramic fabric, add up to 94 kilograms to the mass of the spacecraft. Not only will Bepi Colombo face extreme heat, on the night side of Mercury, temperatures can drop to as low as 180 degrees Celsius, putting the materials under further stress. During the development, ESA had to make changes to its testing facilities at the European Space Research and Technology Center, or ESTEC, in the Netherlands to accommodate the challenging mission. Mercury is the fastest of all of the planets. It is so close to the Sun, it takes just 88 days to complete an orbit. It spins around once on its axis every 59 days. A quirk of Mercury is that each rotation doesn't see the Sun rise and set. Mercury's orbit is more squashed than other planets. This means it actually takes 176 days for the Sun to appear to rise and set. This makes a solar day on Mercury longer than its year. The first spacecraft to visit Mercury was Mariner 10 in 1974, and it mapped around half of the planet's surface. The next mission to Mercury didn't appear until 2004. This mission, Messenger, mapped the rest of the surface. A European mission called Bepi Colombo launched in 2018, but it's not expected to reach the planet until 2025.